Go language programming, Chapter 10, Unit 4. In this unit, we will cover cross-compiling Go language applications. So by default, the Go build command will output a binary suitable for use on current OS and architecture. And that's what we've been doing, right? We just use either go run or go build, so you're just doing it only for the machine that you are actually writing the code on, okay? And of course, you have the Go compiler and is already installed. Now, cross compilation basically generates a binary file suitable to run on different architecture. Okay, so now that is a one big plus for a Go language. When anybody writes a Go application, basically you can make it run on different architecture as long as that architecture is, of course, supported by the Go compiler. Okay, just by using a different switches, and that's what we're going to cover in this unit. Otherwise, in other, like if you are working with a C or C++ code, and if you want to do the cross compilation of your that C++ code, you have to go through a lot of headache, meaning you have to really install the cross compiler. Cross compiler basically meaning that what it will do, it will generate instruction sets. When you compile, it will run on your your host machine, but it will compile the binary for a different architecture. But to do all that, you have to have a cross compiler installed. Otherwise it's not going to work. It's not that easy to install the cross compiler. Well, nowadays, you can just get the package for cross compiler from internet. But if you want to be very specific to be compiling some some specific things for your, like for your operating system or for your kernel, then you may have to build your, well, you have to recompile all the GNU source code to create a cross compiler. Okay, but all that is not necessary for the Go compiler. Go compiler comes with everything. All you need to know is some switches during the compilation, and that's it. And as long as Go compiler supports the different architectures, you are just fine. You compile. You're using, let's say you are using a Linux machine, okay, but you want the code that you have written, you want that code to be able to run on your Windows machine. All you have to do is to cross compile by passing some different flags during the compilation of your code, and that's it. Okay, so basically, it is useful when developing one on a operating system and deploying it on the other operating system. So that's where I was just giving the example. You developed it on Linux, but then same application need to be run on the Windows machine. So you do the cross compilation. So specify the OS architecture, okay, during the compilation to create a binary for by setting the Go OS, okay, and Go architecture, okay, environment variables. These are the environment variables that you have to set it up, okay, and you can do that during the compilation as well. So, and then it will automatically compile your code for that specific architecture. So how you do this? So in this case, right here, example, compile application for Linux operating system that will run on Intel 64-bit architecture. Okay, and for us, for me, I'm using a Ubuntu Linux distribution, and I already have it installed. Go compiler in my Ubuntu Linux environment, so I don't have to go and do all this. It's by default is there, so I just do the go build, for example, directly. So I don't need to set this up because my architecture is Intel now. So in here, as you can see, it says this is an environment variable go OS. So this is the OS meaning operating system name Linux, and go arc is the name of the architecture. As you can see, it says AMD 64. AMD 64 is the same thing as for the Intel machines as well. So the reason that AMD 64 is for, of course, Intel processor, which is a 64-bit processor as well. The reason that the name got stuck with this AMD is because AMD is the one in mid 2000. AMD is the one who came with a 64-bit operating system, that or the 64-bit, not operating system, but the processor. So that means Linux started supporting it, and they named this AMD, and that's why it is AMD. Otherwise, it worked for Intel based or AMD 64 based as well. So when you are, once you set up these environment variables, then you do the go build just like the normal way that you are doing it, and this dash O means output. Okay, so it is going to output this file. Where is it going to output? In this directory. That's where it is going to output. And what is your source code file name? This is myapp.go. That is the source code file name. Okay, so that's how you compile it for the Intel Intel-based architecture running Linux. Of course, if you have that's a default one installed, then you can just do this part. You don't have to set up this environment variable. Okay, compile application for Windows OS. Okay, that will run on Intel 64-bit architecture. So it's a 64-bit Windows running on the Intel architecture. So you do OS Windows, instead of a Linux, and then Go architecture, which is the same as this one, AMD 64, and then you just do this same way, the same command, go build, and then output file name. This will be the output file name, and this is the input file name. Now once it compiles, the binary will be you can run that binary only on your Windows machine. Okay, because it can only understand the instruction sets that your Windows operating system recognizes it. Okay, that's why you cannot run this binary on your Linux machine or on your Macintosh machine. Okay, and then if you have to compile this application for Linux OS that will run on ARM. ARM is the architecture that is very popular these days, and which is used mostly for the small devices or embedded devices. Okay, and you can actually compile your code on your host machine, on your regular Linux machine, or even if you have installed the Go compiler on your Windows, you can also compile it exactly like this on your Windows machine as well, and tell it that it is going to be ARM. See, so it says ARM, 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 and then this was AMD 64. This is ARM, 64. So basically, that will allow you to generate the instruction sets for this binary that will be recognized by the ARM processor. Okay, so that's how you will find out. Now, if you want to find which architectures are supported by the Go compiler, you can just use this Go tool distribution, dist means distribution list, and it will list all of the architectures that are supported, and those architectures names you can put it right here, and it will compile for that. Your application will be compiled for that particular architecture. As long as it's in this list, you should be able to compile with your Go compiler. Okay, so that's basically about it for cross compiling. That finishes your Unit 4, Chapter 10.